Video, I am going to discuss about the dimension of L. Yesterday, I have given the formula for finding the coefficient of self-inductance, which is denoted by L. And numerically, the coefficient of self-inductance is given by L is equal to E upon delta I upon delta I. This one is what here. Numerically, it is given by L is equal to E upon delta I upon delta T. Numerically means on that time I am not taking the minus sign here. And this is equal to E into del T upon delta I. So when you will write the dimension of L, E means EMF, and that EMF is measured in volt. Time measured in second upon this one is equal to ampere. In this way you can write. At place of volt you can write W by Q. W by Q means W upon Q into second is already here second upon ampere. And as you know, L is equal to dimension of work. You can write here M L square T minus 2. Dimension of second is time. T upon Q, which dimension is AT, and here ampere is A. And this you can write here M L square M L square T to the power minus 1. Even this T is cancelled by this T, and here you can say A into A is A square. So in this way you can say ML square T minus 2, and when you will take A into A square, in numerator you will write A to the power minus 2, and this T is cancelled by T. So in this way, the dimension of coefficient of self-inductance is given by ML square T minus 2 A minus 2. Now, self-inductance of a long solenoid. Let us consider a long air-cooled solenoid of length L, area of cross-section A, and having n turns. इसका मतलब हम क्या लिए हैं, एक सिलेंड्रिकल कोर लिए हैं, और उस सिलेंड्रिकल कोर में क्या है, मीडियम एयर, और उसके ऊपर वायर बाइंड किया गया है. And number of turns in that one is how much here? And area of that solenoid A, and length is L. Then the coefficient of self-inductance, of that long air solenoid is given by mu naught n square E by L. Be careful about this one. Here in the core of solenoid, air is present. No any other medium. Air. So air means here I am taking the mu naught T. So in this way you can find out directly the self-inductance of long solenoid. Only you learn the formula. Now the energy is stored in an inductor. Suppose an inductor of coefficient of self-inductance is L, and when through a battery a current I is set up in that inductor here, then the energy is stored in that inductor is given by that U is equal to half L I square. So please all of you know this formula. Energy is stored in an inductor, and the formula is U is equal to half L I square, and this formula is frequently used to solve the numerical problem here. Now next topic is mutual induction, and like the self-induction, now the next one is the mutual induction. And according to this mutual induction, remember this, in the self-induction there I have taken only one coil, and in the same coil when we pass the current, then due to the change in the magnetic flux, an induced EMF is set up in the same coil. तो वहां पे एक कॉइल में करंट फ्लो कराते थे और उसी कॉइल में इंड्यूस करंट भी डेवलप होती थी. But in the mutual induction, here we will take two coils. So if two coils be placed near each other, and if the current is passes through one of them, or if the current is already passed, then that current is changes or current stop. हमने तीन चीजें बताया. If the two coils be placed near each other and in any one coil, either we start the current or if the current is already flow, then we change the current or we stop the current. Then in this case, the second coil which is near this one, the induced EMF is set up. It means the magnetic flux passes through it will be changes here. इसका मतलब अगर प्राइमरी कॉइल में और इन दोनों कॉइल में से एक पहले वाली को हम कहते हैं प्राइमरी और दूसरे वाले क्या कहते हैं सेकेंडरी. तो प्राइमरी कॉइल में या तो करंट को स्टार्ट किया जाए या तो करंट ऑलरेडी अगर इसमें फ्लो कर रही है तो उस करंट को चेंज किया जाए या करंट फ्लो कर रही है और की को सडनली ओपन कर दिया जाए. तो इन सारे केसों में सेकेंडरी कॉइल से पास होने वाली मैग्नेटिक फ्लक्स क्या होती रहेगी चेंज. और जब मैग्नेटिक फ्लक्स चेंज होगा तो सेकेंडरी कॉइल में एक इंड्यूस्ड ईएमएफ सेटअप हो जाएगा. एंड दिस फिनोमेना इज कॉल्ड व्हाट हियर म्यूचुअल इंडक्शन. एंड सपोज आई एम टेकिंग हियर टू कॉइल्स. First coil is, as you know, called primary coil, and secondary, this one is what is secondary coil. Both coil will kept near each other. दोनों पास रखे गए हैं. And in the first coil, there is a rheostat. This one is a source of current, cell or battery, and this one is a key. And when the key is closed, here what I have written here, on pressing the key. On pressing the key means when key is closed. So when key is closed, suddenly in the beginning when the key was open, जब पहले की ओपन रहा होगा तो इसमें कोई करंट नहीं रहा होगा और जब इसमें कोई करंट नहीं है तो इसमें कोई इंड्यूस ईएमएफ भी सेटअप नहीं हुआ होगा. लेकिन एज वी क्लोज द की, जैसे की को हम प्रेस करेंगे, एक करंट विल टेक्स प्लेस इन दिस प्राइमरी कॉइल एंड दैट करंट इज रीचेस फ्रॉम 0 टू ए स्टेडी वैल्यू. इसका मतलब इसमें करंट एक स्टेडी वैल्यू तक बढ़ी होगी. तो इससे पास होने वाली मैग्नेटिक फ्लक्स भी इसके करंट के कारण चेंज किया होगा. एंड an induced EMF is set up in that one, and that induced EMF, since the coil be closed, so that induced EMF is also the cause of the induced current. वो induced current क्या किया होगा, इसके बढ़ने के करंट के बढ़ने का क्या करेगा, अपोज करेगा. इसलिए ये करंट अगर क्लॉकवाइज इस कॉइल में फ्लो कर रही होगी तो इसमें करंट किसमें फ्लो करने लगेगी, एंटी क्लॉकवाइज. लेकिन यहाँ पर हमने क्या कहा, when key is closed, then current increases from 0 to a steady value. Then the induced current in this coil, secondary coil, will oppose the rise of current in this primary coil. Second case is what here? Again, already the current is reaches to a steady value, 0 to a steady value. And when this key is suddenly open, अब हम इसी की को जो यहाँ पहले क्लोज की थी, इसी को सडनली ओपन कर दिया. So when key is open, now here the current is decreases from steady value to 0. इसमें करंट खत्म हो जाएगी. इसका मतलब करंट खत्म होने के लिए क्या हुआ, स्टेडी वैल्यू पे तो पहले थी और स्टेडी वैल्यू से घट के कितनी हो गई, या 0. तो इसमें करंट घटा. तो अगेन द इंड्यूस्ड ईएमएफ व्हिच इज सेट अप इन दिस वन is want to increase the current. क्योंकि इसमें करंट घट रहा है, इसलिए इसमें जो इंड्यूस करंट था वो चाहेगा कि इसके करंट को हम क्या कर दें, बढ़ा दें. एंड फॉर दिस पर्पस the direction of the current in this secondary coil will be what here, again becomes what, same like this primary. So in this way you can find if the two coils be kept very close to each other, and in any one of the coil, if either we start the current or change the current or stop the current, then through the secondary coil an induced EMF is set up. If in the primary coil current increases, then in this secondary coil the direction of the current is opposite this one. Means if this current is clockwise, so the current in this one will be what here, anti-clockwise. लेकिन अगर इसमें करंट घटेगी, ये अपने करंट को इसमें क्या करेगा, ये चाहेगा इसके करंट को बढ़ाएंगे. तो in that case the direction of the current in the secondary coil is same as the direction of the current in the primary coil. And like the coefficient of the self-induction, also we can calculate the coefficient of mutual induction. But here I want to tell one more important thing. In the core of primary and secondary coil, अगर ये प्राइमरी सेकेंडरी कॉइल जिस पर बाइंड किया गया है उसके कोर में हम कोई मैग्नेटिक मटेरियल डालें, जैसे आयरन डालते हैं, when we insert the iron in the core of primary and secondary coil, then in this case the induced EMF in the secondary coil will be what here increase. तो क्या हो जाएगा, induced EMF इस केस में क्या करेगी, बढ़ जाएगी. And here remember this, here induction coil and transformer both is works on mutual induction. Earlier we have said this one, the transformer works on the phenomena of electromagnetic induction. But in the electromagnetic induction, what type of induction occurs there? So what induction? Mutual induction. So remember this, induction coil and transformer based on the principle of mutual induction. Now, coefficient of mutual induction. Suppose I1 be the current which is passes through the primary coil. याद करिए हमने प्राइमरी कॉइल में सोर्स ऑफ करंट से हमने करंट को फ्लो कराया. तो लेट I1 be the current flows in the primary coil, and due to this current I1, the flux linked with each turn of secondary coil is phi2. इसका मतलब जब प्राइमरी कॉइल में करंट I1 है तो इस प्राइमरी करंट I1 के कारण सेकेंडरी कॉइल के हर एक टर्न से कितनी मैग्नेटिक फ्लक्स पास हो रही है, phi2. If N2 be the total number of turns in secondary coil, then what is the total magnetic flux passes through the secondary coil? N2 phi2. And this N2 phi2, it means total magnetic flux passes through the secondary coil, which is N2 phi2. That total magnetic flux is directly proportional to the current flow in primary coil, or simply you can say that current is how much here, I. And here I want to tell you, if I am using 1 means I am taking for primary, and if I am writing 2 means for secondary. So total magnetic flux passes through the secondary coil is directly proportional to the current flowing in the primary coil. And when we remove this proportionality constant, then we will introduce a new constant. And what that new constant? M into I. And this M is called where? M is called coefficient of mutual induction. And from here you can say M is equal to N2 phi2 upon I. And this is find the coefficient of mutual induction. But by Faraday's law, also we can find by the Faraday's law, induced EMF. अब बताइए induced EMF किसमें सेटअप हुआ है, सेकेंडरी कॉइल में. Then the induced EMF in the secondary coil is given by E2 is equal to minus N2 delta phi2 upon delta T. This one is what here, induced EMF setup in the secondary coil. Remember this, 2 represent for secondary. The total induced EMF setup in the secondary coil is equal to minus N2 delta phi2 upon T. Or we can write here E2 is equal to minus delta, you can write here N2 phi2 together upon delta. And at place of N2 phi2, you can write Mi1. So here at place of N2 phi2, write out Mi1. So E2 is equal to minus delta Mi1 upon delta T. And you can write minus M into delta I1 upon delta T. And from here you can say M is equal to, what is M? Coefficient of mutual induction. M is equal to minus E2 upon delta I1 upon this. This is the formula for finding the coefficient of mutual induction, and this formula is same as the coefficient of the self-induction. So coefficient of mutual induction M is equal to minus E2 upon delta I1 upon delta T. And remember this, if delta I1 upon delta T is equal to 1 ampere per second, then M is numerically equal to what here? E2. Numerically equal to E2. It means the coefficient of mutual induction is numerically equal to induced EMF in secondary coil when rate of change of current in primary coil is 1 ampere per second. Again, we here, how can we define the coefficient of mutual induction? Coefficient of mutual induction is numerically equal to induced EMF in the secondary coil when rate of change of current in primary coil is 1 ampere per second. And also I want to tell you here, the unit of coefficient of mutual induction is also Henry. It means the unit of self-inductance, coefficient of self-inductance or coefficient of mutual inductance. The unit of both is what here? Henry. So, and also if you want to write down the smaller unit of inductance, then you can write here millihenry, microhenry. As you know, 1 millihenry is equal to 10 to the power minus 3 Henry. 1 microhenry is equal to 10 to the power minus 6 Henry. So in this way also you can find the smaller unit of coefficient of self-inductance or mutual inductance. So today you go through this topic here, what I have discussed about this dimension of the inductance, either dimension of the self-inductance or the mutual induction. Both is same here. So dimension of L or M is same here, and also you go through how can you find the coefficient of the mutual induction, and also you try to solve the numerical problem based on these formulas. In the next video, I will be discussing about the ED current, and after that this chapter is here.